let's talk about tree diagrams.
Tree.
Like a
There we go.
tree. Okay, so this is a good way of visualizing what's happening in like a probability experiment or something like that. So if we're tossing a coin twice, you always need to look at the stages. So lots of people make a mistake. That's the most common mistake, is what people don't know what to put for the branches. They try they try all sorts of things, but really you have to look at what's happening the first time and then what's happening the second time. So if we're tossing a coin, the first time we can either get heads or we can get tails.
Yeah.
And then the second time, well, it's exactly the same. And that can tell us, what the possible outcomes are. And then, you can go off and list them all. So that's the basic tree diagram from year 8.
Yeah.
But once we get to year 12, we start adding numbers and it gets a lot more complex. So if we look at, say, planting a garden, or plant a tree in the garden, and we are not great gardeners, but we're okay. So we've got a 90% chance that the tree will live, and a 10% chance it will die. Okay, 10% that it'll die. So if we plant, let's just make it easy. We'll say we'll plant 2 trees. So our first tree and our second tree. So if we plant the first tree, there are only 2 things that could possibly happen. It either lives or it dies.
Yeah.
Second tree has the same possibilities.
Right.
Now, we know from our expert gardening skills that it's either going to 90% chance to live or it's got a 10% chance to die. So we might just make those decimals because that makes it a little bit easier. So we'll say 0.9 chance to live, 0.1 chance to die. Now, all our trees, we treat them the same. We're, equal in our care. So every live branch gets a 0.9 and every die branch gets a 0.1.
Branch.
Yes, branch. Very good.
Yes.
Okay, so if we want to know what the chances of both of our trees living, all we do is we take our first tree living and we multiply it by our second tree living. And this is the way it works for any outcome that we want to look at. You multiply along the branches. So if we want to know what the chances of both of our trees dying, that would be this branch here, and we just times those 2 things together.
Right.
If we want to know that, it doesn't matter which branch we look at. If the first tree dies and the second tree lives, like we still multiply. We can work out all the different situations that are going to happen in our garden, and that will calculate the probability of those situations. And then they can ask us questions saying, that at least one lives. If it's at least one lives, then that's this one or this one. So we have to do both of those. Yeah, like that should get there. So if we want to know one lives and one dies, that's those 2 green bits.
Yeah.
And we work out those. So if we did 0.9 times 0.1, we will get 0.09. But that's for each green one. So they're the same. We multiply by 2 and we get 0.18. So we've got a 0.18 chance of having one live and one die. Or a 0.81% chance, or 0.81 chance of them both living, or the bottom one, or like if they both die, if we're terrible, it'll be 0.01. And then if we take this, this, and this.
So we would have to plus it.
Well, this we could do that times 2 as a plus point, like 0.09 plus 0.09.
Yeah.
So if we add these 3 red ones together, we'll get 100% because that's all the possibilities.
Yeah.
They either both live, both die, or one of them lives and one of them dies, which is 0.09 each, which is 0.18 together. So if, like your question in the trial, if we've got 3 things, we can have good, bad, or neutral with cards. And each thing has its own fraction, so it's a little bit squishy, but you get that. So if we've used a good card in our first selection, we have 1 less, and we've had 50 cards to start with, and now we've got 1 less because we've already used it. Yeah. So as we move along the branches, we will get this effect happening. So that 1 card will go down, the total will go down by 1, and if we've used a good in the first point, there'll be 1 less good one in the second choice. Whereas the bad ones, we haven't used any bad ones, so they'll still be at their full complement.
Yep.
So if we want to know what's the probability that they're both good, well, like we just saw, we just multiply the branches together. So we would do 20 over 50 times 19 over 49.
Yeah.
And that would tell me about having a good card and another good card.
Yeah.
Now, if they ask me, and they always do, this is the favourite question, the least. At least 1. At least 1 good card. Or good outcome, or whatever it is. So this means that we have to have at least 1 good one. So that means we could have 2 good, we could have good, bad, and good, neutral, or we could have bad, good, or neutral, good.
Yeah.
So they all have at least 1. The others don't. So we would have to work out all of those and then plus them all together. Yeah. That's basically how it works. And, sometimes it's easy if there's only 2 outcomes, like if we were doing, like if we did having 3 children, so first, second, and third child. The first child could either be a boy or a girl, and a boy or a girl, etc. The probability of at least 1 boy, well, lots of these are going to have boys in them. How many of them are going to have no boys in them?
1, 2.
Only 1.
Yeah.
This last one, the girl. So I don't need to work out all this other junk.
Yeah.
I just need to work out this one, and then do 1 take away that.
Yeah.
So if the probability, let's say this family, there's more girls in their family than boys, so it's not 1 in 2. Yeah. I mean, biologically speaking, it's 1 in 2, but let's say, for instance, theirs is actually, it's 2/3. They've actually got a 2/3 chance of getting a girl for whatever reason, and their boy chance is 1/3. If I wanted to know at least 1 boy, then I would do 1 take away. I'd just do the one where it's all girls, and I wouldn't worry about doing anything else, because all of this, like, there are 7 other outcomes here.
Yeah.
There's, because there are 8 possibilities altogether for having 3 children, so 2 times 2 times 2. So you could work out all 7 and you could add them together, or you could just do one takeaway, just the one you don't want.
Yep.
The one where you've got 3 girls. Okay, so that's the trick with at least. Whereas that last one's a bit different because it's got 3 outcomes. So you do have to work out each one and then add along the times along the branches and add the different branches that you want together.